All right, this is section 2, topic 5, special types of angle pairs formed by transversals and non-parallel lines. So here we've got two lines right here that are the non-parallel lines that they're talking about. And this one that's cutting across them is called the transversal. Many geometry problems involve the intersection of 3 or more lines. What observations can you make about the angles in the figure? Well, when we've got these lines all crossing each other, we have a lot of angles that sit together on a straight line. Remember, that's called a linear pair. We have a lot of vertical angles happening, right? We've got all kinds of pairs of vertical angles, all kinds of linear pairs going on everywhere. So many linear pairs and vertical angles. All right, lines L1 and L2 are crossed by line T. Line T is called the transversal because it intersects two lines, L1 and L2. The intersection of line T with L1 and L2 forms 8 angles, which we have labeled here A through H. Identify angles made by transversals. Consider the figure below. All right, so we have the same picture that we had before. Angle A and B form a linear pair. Box and name the other linear pairs in the figure. All right, so I'm going to use different colors here for this. This is a linear pair. They sit together on that line right there, okay? So angle C and angle D, that's a linear pair. We have angles E and F together on this line right here. So that's a linear pair. And we have angles G and H. That sits together on this line right here. So that's a linear pair. But we also have these going on. So we could say angle B and D is a linear pair, right? And so is angles A and C. And angle F and H together make a linear pair. And angle E and G together make a linear pair. So we've got a ton of linear pairs going on right here. I've already named those 3. So we can also say, and these others, angle A and angle C, angle B and angle D, angle E and angle G, angle F and angle H. All right, lots of different pairs that are linear pairs. All right, let's keep looking at that same figure. And this time let's talk about vertical angles. So we talked about vertical angles a couple lessons ago. E and H right here, opposite angles, another word for that. It's vertical angles, so there you go. Box and name the other pairs of vertical angles in this figure. All right, so we have angle F and angle G. Those are vertical angles. And remember, vertical angles are congruent, the same measures. All right, angle B and angle C. And our last pair here is angle A and angle D. Okay, so we've named all the vertical angles. So angle E and angle H. I think I'll go ahead and write that on there since we have labeled all the rest of them. There we go. So these are all the pairs of vertical angles. Let's go to the next page. If I can get that one to move. All right, back to that same figure again. Which part of the figure do you think would be considered the interior? Draw a circle around the interior angles in the figure. Justify your answer. Okay, interior, it's like the interior of your car, right? It's inside something. And so here we've got our outer lines. Think of those as being the boundary lines. What's inside those boundary lines? Well, you've got all of these right here, right? The interior would be inside those two lines. And draw a circle around the interior angles. Here you go. Those are your interior angles. Interior means inside. They are between lines L1 and L2. Okay? Which part of the figure do you think would be considered the exterior? Draw a box around the exterior angles in the figure. Okay, so if that's the interior, it would make sense that the exterior would be up here and down here. So we're just going to put that here. Exterior is outside those lines. Okay, interior, exterior, without the middle part. Okay, draw a box around those exterior angles. Here they are, A, B, G, and H. Exterior means outside. It's outside lines L1 and L2. All right. Looking at that same figure again, consider the figure. D and E are alternate interior angles. Okay, so the first thing is they're angles. They're in the interior, which is the center here, and they are alternating. So if you are standing on your 2 feet and you start alternating which foot you are leaning on or standing on, you'd stand on this foot and then you'd stand on that foot and stand on this foot and stand on that foot. And you're alternating feet, right? Alternating means on opposite sides of that transversal that's cutting down through the center. So first I'm on one side, then I'm on the other. Alternate sides. So D and E, you can see, are on alternating sides of the transversal, and they're in the interior of our figure. Right here, the interior, and on alternating sides. I guess we can write here, opposite sides. Okay. Notice how D and E are in the interior regions, but on opposite sides of the transversal. Draw a box around another pair of alternate interior angles in the figure. All right, well, there are only 2 other angles in the interior of it, and they are on alternating sides of that transversal. So there we go, angle C and angle F. All right, now moving on, let's look at alternate exterior angles. Okay, this would make sense. Alternate, opposite sides of the transversal. Exterior means outside those 2 lines, those 2 not parallel lines that we have going on right here. Notice how B and G are in the exterior region, right? Exterior. But on opposite sides of the transversal, they're alternating sides. One side, one side, one side, other side. Draw a box around another pair of alternate exterior angles. Okay, another pair of alternate exterior. They have to be outside. So here's A and H. There we go. All right, moving right along. Okay, again, now let's look at corresponding angles. Notice how angle B and angle F have distinct vertex points. So this one has this vertex and this one has this vertex. And they lie on the same side of the transversal. So they're not alternating sides of the transversal, right? They're on the same side. However, angle F is in the interior region and angle B is in the exterior region. Draw a box around another pair of corresponding angles. All right, corresponding, what I like to think of this is I have 3 roads in town, right? And there's an intersection here and an intersection here. And these are the corners that have stores on them on both intersections. And there's a joke that, you know, on every corner of on every intersection, you have a convenience store. So let's think 7-Elevens. So if this is the 7-Eleven here, then, and we have a 7-Eleven on the same exact corner at the next intersection down, it would be sitting right here. Another example, you have a Walgreens at corner A right here. If you have a Walgreens on the same exact corner in the next intersection down, where would it be sitting? Well, it'd be sitting right there at corner E, right? So Walgreens, Walgreens, 7-Eleven, 7-Eleven. You have a Publix at corner D, and you have another one at the same exact corresponding corner at the next intersection down, it would be at corner H, right? Those are corresponding angles. Same corner, different intersection, if you want to think of traffic. All right, so draw a box around another pair of corresponding angles in the figure and name them below. All right, well, we talked about angle A having Walgreens on it, and then angle E also having a Walgreens on it. So angle A and angle E are corresponding. Let's go ahead and do another one. Angle C, what's its corresponding angle? It's in the same location, different intersection down the road. There it is, angle G. And we might as well just go ahead and name the last one here. So let's do angle D. And at the same position, next intersection down is angle H. Right, consider the figure here. Angle C and angle E are consecutive, that's kind of new, consecutive or same side interior angles. All right, remember again, this is our interior here between these two lines. C and E are consecutive. And when we talk about consecutive numbers, we mean the very next one, all in a row, right? Or one right after the other. So I'm going to write that here, one right after the other. And you can see that C, if we travel along in the interior, the very next one would be E, right there. Same side though, same side interior angle. So we're not talking about C with D. Those are adjacent angles. Notice how C and E have distinct vertex points. They're at 2 different intersections in our town and lie on the same side of the transversal. However, both angles are in the interior regions. Draw a box around the other pair of consecutive interior angles. All right, the other pair of consecutive interior angles. Same side, interior. That's angle D and angle F. Okay, moving right along. Sorry, you can, never mind, I won't get there. All right, on the figure below, Park Avenue and Bay City Road are non-parallel lines crossed by transversal Mount Carmel Street. The city hired GeoNet Road Service to plan where certain buildings will be constructed and located on the map. And we have Park Church, Library, Police, School, Hospital, Fire, and City Building. Position the buildings on the map by meeting the following conditions. Okay, now I have looked at this one before, and I'm going to tell you that there's a couple different ways to do it depending on where you put your starting one. Unfortunately, none of our clues here specify a specific street or intersection, so we could do this, the answer could work out in a variety of ways. So let's start with the park and the city building form a linear pair. Line, pair on the same line, which means they are right next door to each other, right? So let's put park and city building right next door to each other. The city building and the police department are at vertical angles. All right, remember vertical angles means one's here, one's there, right? So city and police. The police department and the hospital are at alternate interior angles, alternating sides of our transversal, both in the interior. Police, interior here, police and hospital. Alternating and in the interior of the two lines. The hospital and the fire department are at consecutive interior angles. They're both in the interior, that's this right here, And consecutive, one right after the other, one right next to each other. So hospital, fire. The school is at a corresponding angle with the park. Okay, that means the same angle. That means the corner that the park is on in this intersection, the school is on the same exact corner in the next intersection down. So corresponding means same place, different intersection. So that's your school. And a consecutive interior angle to the police department. Okay, that makes sense. Consecutive interior, one right after the other, both in the interior. The library and the park, here's the park. The library and the park are at alternate exterior angles. So remember, the park is in the exterior, and so is the library, and on alternating sides. So park, library. The church is at an exterior angle, better be that one right there, and it forms a linear pair with both the library and the school. So there you go, there's our church. It sits as a linear pair with the school and as a linear pair with the library. There you go, that worked. Next page. Consider the figure. Which of the following statements is true? If angle A and angle E lie on the same side of the transversal, they do, and one angle is interior and the other is exterior, then they are corresponding angles. Corresponding. Remember back when we looked at corresponding angles, we said that that meant that it was like the 7-Eleven on this corner, there's another 7-Eleven on the same exact corner. So this looks like it's probably true. If B and H are on the exterior opposite sides of the transversal. Okay, well, first of all, B and H are not on opposite sides of the transversal, are they? They're on the same side of that transversal right there. So this is already having some problems. They're alternate exterior, they're not alternating, right? They're exterior angles, but they're not alternating sides. This is definitely not an answer. If angle B and angle C are adjacent angles, okay, those are not adjacent. Adjacent means next door neighbors. These guys are sharing a vertex, but they're not sharing a fence between them, right? Those are not adjacent. And it says lying on the same side of the transversal, then they are same side consecutive. They're not on the same side. They're not consecutive. Ooh, that's really bad. If angles B, C, and G, B, C, F, and G are between the non-parallel lines. Okay, well, there's our non-parallel lines. And I can tell you right now that B is definitely not between those lines, and neither is G. So that one's got some problems too. So we're going back to A. That is definitely our answer. All right, beat the test. Consider the figure. Match the angles on the left with their corresponding names on the right. We've got alternate interior, consecutive, corresponding, all those ones that we just did. This is like a little quiz. This would be great as a mini quiz. Angles 1 and angle 7. Okay, these are exterior, right? In fact, if we need to label exterior so that we remember that, and this is the interior, maybe we need to do that. All right, so 1 and 7 are definitely exterior, and they're on alternating sides of that transversal, right? That makes them alternate exterior angles. 5 and 6. All right, 5 and 6. They're on the same side, right? They're sitting there together, and they're in the interior. They're on alternating, they're both in the interior. They're on alternating sides of our transversal, but they're sitting right next to each other on a line. And when you have two angles sitting together on the same line, that is a linear pair. Okay, 4 and 6. Let's get a different color here. 4 and 6. All right, 4 and 6 are both on the same side of our transversal, so they're not one of the alternate ones. We can forget A there, it's not alternate. They're both on the interior, and they're one right after the other, and that is consecutive angles. Okay, consecutive. I switched colors there. All right, let's see. 5 and 7. All right, here's 5, here's 7. They are formed when two lines cross each other, right? Directly opposite each other. Oh, opposite. They're opposite angles. And opposite angles is another word for vertical angles. 4 and 5. Let's look at 4. I'm getting a lot of colors in here now. 4 and 5. Okay, I can see already that they're both in the interior. That's helpful. And they're on alternating sides of the transversal. So alternate interior angles, which is A. And 3 and 8. 3 and 8 are in the same location, aren't they? Same location down the road from each other. So like 7-Eleven here, 7-Eleven on the same exact corner. Those are corresponding angles. See, there we go. All right, that is the end of a pretty long lesson.